before discussing the cluster analysis, let me discuss about the factor analysis. I think which had been told previous days. So what we do in factor analysis, that is a dimension reduction technique where we reduce the dimension in terms of the variables, in terms of the characteristics. So what we do, we cluster the we group the different similar characteristics, while in cluster analysis on the basis there in factor analysis, what we do, we club or group the characteristics for the units under consideration. But in cluster analysis, what we do, we cluster or group the units on the basis of all the characteristics under consideration. So there we group the similar characteristics, while here we group the similar units on the basis of different characteristics under consideration. So let us start what is cluster analysis. So cluster analysis is a group of multivariate techniques whose primary purpose is to group objects. Here we group the objects, while there we in factor analysis we group the characteristics. That is respondents, products or other entities based on the characteristics they possess. So it is a means of grouping records based upon attributes. So here we group the records, or we group the units on the basis of the characteristics of the units under comparison. That makes them similar. So here we group the similar characteristics based on all the attributes, all the characteristics. We group the units, similar units, and there in factor analysis we group the similar characteristics of the units. So if plotted geometrically, the objects within the clusters will be closer or close to each other, while the distance between clusters will be farther apart. So that is the difference in later we will be discussing why distance is the measure for cluster analysis and the correlation is the basis for the factor analysis. How distance is different from that correlation, and that is why distance has been made as the basis for the cluster analysis, while the correlation is basis for the factor analysis. So okay, so cluster variate represents a mathematical representation of selected set of variables which compares the object similarity. So here we check the similarity of the objects based on all the characteristics under consideration. So here, see here, cluster analysis versus factor analysis. What we do in cluster analysis, it is the grouping based on the distance, proximity. While in factor analysis, what we do, we group the units based on the patterns of variation. That is, there we calculate the correlation matrix. So factor analysis, we form group of variables based on the several people's responses, that is characteristics, to those variables. And in contrast to the cluster analysis, in cluster analysis, we group people or unit based on their responses to several variables. So this is, counterpart of that. We group the different similar variables there in the factor analysis, and here in cluster analysis, we group the similar units based on all characteristics. So what is the difference between this, cluster analysis versus discriminant analysis, which we will be discussing tomorrow. In cluster analysis, you don't know who or what belongs to which group in cluster analysis. Not even the number of groups. We don't know the number of groups in advance. We don't know which unit is going to belong to a particular group, particular cluster. Later we'll be discussing finite grouping or say without having the idea of the group. And in discriminant analysis, it requires you to know group membership for the cases used to derive classification rule. There we define the discriminant function. On the basis of that, we assign the unit to the particular groups. There we know the groups. So on the basis of the membership, that is the discriminant function, we decide whether it will be put in the particular that group or this group or that group. Here we don't know the number of clusters, and though we don't know even the unit is going to which cluster. Now these are the applications of the cluster analysis, where we group the similar units on the basis of the all characteristics of the units under consideration. So in the field of psychiatry, where the characterization of patients on the basis of the cluster of symptoms can be useful in the identification of the appropriate form of the therapy. So what we will do, we will cluster different patients on the basis of their characteristics, and will decide which therapy should be given to a particular group. That is known as the cluster. And in biology, we use to find groups of genes that have similar functions. So on the basis of different functions, we will cluster different genes, and then we can do some analysis of different group of genes or clusters of genes. In information retrieval, we would the World Wide Web (WWW) consists of billions of web pages, and the results of a query to a search engine can return thousands of pages. As we see, suppose we just click cluster analysis, so you will find different pages, 1, 2, 3, so on, and so on the basis of the similarity, you will find first, second, third, and so on, this way. So there, this is applied there. So see, thousands of searches are there at the search engine. So thousands of pages are there. So clustering can be used to group these search results into a small number of clusters, each of which captures a particular aspect of the query. So on the basis of that, you can group different results which are similar in nature based on different characteristics defined in advance. So for instance, a query of movie might return web pages grouped into categories such as reviews, trailers, stars, and theaters. Each category, that is cluster, can be broken into subcategories, that is subclusters, producing a hierarchical structure that further arises a user's exploration of the query result. Maybe in art movie, maybe commercial movie, and this like that. So how we use this cluster analysis in climate science? So to understanding the Earth's climate requires finding patterns in the atmosphere and ocean. To that end, cluster analysis has been applied to find patterns in the atmospheric pressure of polar regions and areas of the ocean that have a significant impact on the land climate. So there we will cluster the areas on the basis of the characteristics. Now the common roles cluster analysis can play. So these are some common roles where it is also used in data reduction, what is done in factor analysis. So a researcher may be faced with a large number of observations that can be meaningless unless classified into manageable groups. Suppose we are dealing with a big data, but it is meaningless if we are not classifying them into different groups so that we may be able to manage them. So cluster analysis can perform this data reduction procedure objectively by reducing the information from an entire population to sample to information about a specific group. So this way we can make different clusters on the basis of the similarity of the objects under consideration. So, and hypothesis generation, it may also be used in the hypothesis generation. Cluster analysis is also useful when a researcher wishes to develop hypotheses concerning the nature of the data or to examine previously stated hypotheses. So there, on the basis of that characteristics, we can club, we can group, we can cluster different hypotheses or different, say, statements. Now, what are the most common criticism with the cluster analysis? So there are many attributes, many characteristics of the cluster analysis, and at the same time there are some criticism with the CA. So cluster analysis is descriptive, atheoretical, and non-inferential. This is said that it is atheoretical, means theory, there is no such theory to support it, and it is non-inferential, it means we are not getting so much information, we are going to have some inferences about that particular population under consideration. So cluster analysis has no statistical basis upon which to draw inferences from a sample to a population. It means we are not in a stage to estimate the population parameters on the basis of the sample information through this technique. And many contain that it is only an exploratory technique. So it is considered as the exploratory analysis, exploratory data analysis. So nothing guarantees unique solutions, because the cluster membership for any number of solutions is dependent upon many elements of the procedure. You can use a hierarchical, non-hierarchical, and this way you can make different number of clusters, so that the characteristics definitely will be changed if the membership is changed from one cluster to another. So definitely there is no such basis, theoretical basis, so that we may have a unique solution or say unique inferences about the parameters under consideration. So if you are changing the clusters, you are getting different information. So that is why we can't say that it is a strong basis to have some solid estimates for the parameters under consideration, or robust estimates of the parameters under consideration. Okay, so and many different solutions can be obtained by varying one or more elements. So you are putting one element to another cluster, another element to another cluster, so the solution will be changed. So cluster analysis will always create clusters regardless of the actual existence of any structure in the data. See, we find some structure in the data, but it don't bother about that. CA don't bother about the original structure in the data. It creates the clusters regardless of the actual existence of the structure in the data. So when using cluster analysis, the researcher is making an assumption of some structure among the objects. The researcher should always remember that just because cluster can be found does not validate their existence. Definitely. So only with strong conceptual support and then validation are the clusters potentially meaningful and relevant. So on the basis of the practice only, we see which one is going to be, meaningful, and it is some relevant to the analysis. So the cluster solution is not generalizable. We cannot generalize the solution of the cluster analysis. It is totally dependent upon the variable used as the basis for the similarity measures. So if you are changing the number of variables, say number of characteristics, so the analysis will be changed. So it depends on the number of This may be the number of characteristics may be considered for the as the basis for the cluster analysis, and definitely the analysis will be changed if the number of characteristics are changed. So this criticism can be made against any statistical technique, but cluster analysis is generally obviously we can put this criticism to any of the statistical analysis, but some of them are very robust regarding the change of some characteristics. But if some characteristics are impacting the result, impacting the estimate, then definitely this will be applicable everywhere for the statistical analysis. But in cluster analysis, it is generally considered more dependent on the measures, the characteristics under consideration, used to characterize the objects than other multivariate techniques. So with the cluster variate completely specified by the researcher, as a result, the researcher must be especially cognizant of the variables. So we should be very much conscious about selecting the characteristics under consideration while doing the cluster analysis of the variables used in the analysis, ensuring that they have a strong conceptual support. Then they must be considered into the analysis while doing cluster analysis. So what are the objectives of the cluster analysis? Cluster analysis used for taxonomy description, identifying group within the data simplification, the ability to analyze group of similar observations instead of all individual observations. We just see the objects of the similar observations, and relationship identification. The simplified structure from cluster analysis portrays relationship not revealed otherwise. So sometimes we get some information, some relationship which was not revealed through the original structure of the data, but it is revealed through this cluster analysis. So theoretical, conceptual, and practical considerations must be observed when selecting cluster variables for the CA. So to see directly, we are not having some theoretical or conceptual concept while applying the cluster analysis, but we can apply these while selecting the characteristics of the units through which we will be applying the cluster analysis. So some conceptual, practical, and theoretical considerations must be applied while selecting the clustering variable, or say the characteristics of the units under consideration. So only variables that relate specifically to objectives of the cluster analysis are included, which are fulfilling the objective of the cluster analysis. They must be included into the cluster characteristics list. So variables selected characterize the individual, that is objects being clustered. So these variables decides the similarity among the units or individuals under consideration. Now, how does cluster analysis works? This is very important. The primary objective of cluster analysis is to define the structure of the data by placing the most similar observations into groups. So first thing is to decide the characteristics, that is clustering variables. And on the basis of the clustering variables, we club the similar units, most similar observations into groups. To accomplish this task, we must address three basic questions. So while applying the cluster analysis, while doing cluster analysis, we must look into these three questions. Number one, how do we measure similarity? It means what is the basis for the measuring of the similarity of different units under consideration, distance measure and the other things. How do we form clusters? what is the mechanism for making the clusters? Hierarchical, non-hierarchical, hierarchical are the combination of them. And how many groups do we form? And it is very important how many clusters we are going to form. So we have to put 3 questions. What is the measure of the similarity? What is the basis for making the clusters? And how many clusters we are going to make? So now the 3 things we will be discussing: measuring the similarity, how do we decide the number of clusters, and how many clusters. So similarity represents the degree of correspondence among objects across all of the characteristics used in the analysis. Definitely we define the similarity of the objects under consideration on the basis of the all characteristics of the objects. So it is a set of rules that serve as criteria for grouping or separating items. So these are the characteristics are the criteria which decides which units are similar, and so put them together or apart. And the second thing is correlational measure, less frequently used, where large values of R do indicate similarity. So we will be showing some drawback of this correlational measures. This is used in the factor analysis. This is basis for that. Now the second is, that is, similarity is measured on the basis of 2 major factors: correlational measures and the distance measures. So most often used as a measure of similarity, with higher values representing greater dissimilarity. It means it is far from that. High distance means the 2 objects are very far to each other. So distance between cases, not similarity. Now see, this is very, interesting example, and we can have a very clear idea why distance measure is taken into consideration for cluster analysis. See here, graph 1 and graph 2. Here we have some 4 categories, and say here we have 2 groups, and here also we have same group. So both graphs have the same R equal to 1, perfect correlation, because the points are having equal pattern. The 2 graphs are having equal pattern in both the graphs, so the correlation is 1, which implies to have a same pattern. R equal to 1 means they are having same pattern, but the distances are not equal. Here this is very, less distance in comparison to this one. So that is why in cluster analysis we use the distance measure. Now distance measures, how many types of different distance measures we use while doing the cluster analysis. So different distance measures are available, and they are used for this cluster analysis. Euclidean distance, the most commonly recognized to as a straight line distance. So this is the difference between the points: xb minus xc whole square plus yb minus yc whole square. These are the 2 observations, 2 characteristics. Squared Euclidean distance, this is the square of this one. The sum of the square differences without taking the square root. It means if you remove this square root, so that this will be the squared Euclidean distance, that is xb minus xc square plus yb minus yc whole square. Now city block Manhattan distance, Euclidean distance, uses the sum of the variables absolute differences, that is Manhattan distance or city block distance. So here we take the absolute differences of the points. So a mod of xb minus xc plus mod of yb minus yc. Chebyshev distance, is the maximum of the absolute differences or difference in the cluster variables values. Here we will see how many, the values we will be using of for XB and XC, and will be taking the maximum of this difference, So that will make the Chebyshev distance. Frequently used when working with the metric or ordinal data, that is, non-metric or say ordinal data. So the distance, Chebyshev distance is considered as the maximum of the absolute distances of different points. Now Mahalanobis D square, it is very important and very efficient measure of distance. So it is a generalized distance measure that accounts for the correlation among variables in a way that weights each variable equally. So here what we do, we assign equal weights to every point under consideration while applying this Mahalanobis D square. So see here, this is Euclidean distance, this is city block distance, and this is Chebyshev distance, the maximum of the two distances. Now see, let us discuss it with an example. So suppose a marketing researcher wishes to determine market segments in a community based on patterns of loyalty to brands and stores a small sample of 7 respondents as a pilot test of how cluster analysis is applied. 2 measures of loyalty, V1 and V2, that is store loyalty and the brand loyalty, were measured for each respondent on 10-point scale. So here we are having 2 characteristics, that is store loyalty and brand loyalty, and we are checking the loyalty of purchasing the objects are say under consideration. So here we have taken the observation on 10-point Likert scale, and you can see here the data values are here. These are the respondents and these are the clustering variable, that is characteristics under consideration. So one is brand store loyalty and another one is brand loyalty. So here we have A, B, C, D, E, F, and G. So we have 7 respondents. Pilot survey has been applied to 7 respondents, and these are their scores on the 10-point scale. So respondent 1 has given 3 out of 10 to store loyalty, and similarly B, C, D have given 4 2 points. They have given very poor points to store loyalty, and 6, 7, 6 E, F, and G has given for the store loyalty. Now for brand loyalty, these scores are 2, 5, 7, 7, 6, 7, and 4 by different respondents A, B, C, and G. You can see here, these are, so on the basis of V1 and V2, the pair of observations will be plotted here. A is nothing but, it is the pair of observation 3, 2, 3 and 2. So 3 on V1 and 2 on V2. So let us see 3 on V1, this point, and 2 on V2. So this point will be the A. Similarly, these are the objects on the basis of different characteristics. Now we will see the distances between the points on the basis of the all characteristics. So how do we measure similarity? Proximity matrix of Euclidean distance between observations. So what we do in Euclidean distance, we take the differences and we square the units and add them, and then take the square root of the for all observations under consideration. So see here, you can see we have 7 respondent, and they have given different values to the 2 characteristics to all 7 units on the basis of the two characteristics. So see here, this is a distance between A and A is 0, and distance between A and B is 3.162. How it has come as 3.162? Let us see the distance between A and B. So what we will do, on the basis of all characteristics, we will take the differences between for all the all the units. So we have considered two units, A and B. So we will consider the difference in the observations of the first characteristics, and we'll take the square, and for other characteristics as well. And here we are considering only two characteristics, that is I mean store loyalty and the brand loyalty. So here you can see V1A minus V1B square, that is 3 minus 4. You can see here V1A and V1B, 3 and 4. So 3 minus 4, and V2A minus V2B, 2 minus 5. So you can see here that is 2 minus 5, and the value comes out to be 3.162. Similarly, we can consider, we can calculate all the distances between A to B, A to C, A to D, A to E, and A to F, A to G. Then B to C, because B to A we can write here, but we have taken only the diagonal values, because it will be symmetry to this lower triangular observations. So here you can see B to A will be this one, and B to B will be 0, because that is similar, same point. And B to C this one, B to D this one, B to N. This way we can calculate through these points. So B to C or A to C, B to C, 4 minus 4, 5 minus 7. Similarly, A to C, 3 minus 4, 2 minus 7, and square of that, then take the square root of the sum. So, okay. So how do we form the clusters? You can see here we can we can add one by one similar clusters. Then we put the observations similar to each other in a cluster. Then we put the whole cluster to the similar unit. Then we make the hierarchical type cluster. So you can see here, this is agglomerative process and this is cluster solution. So there are two divisible and agglomerative process. We can make by adding all cluster to one cluster, similar, and or make the whole cluster and then divide them into subclusters. So that is divisible in procedure. So in step 1, 2, 3, and 4, the OSM does not change. Overall similarity, which indicates that we are forming other clusters with essentially the same heterogeneity of the existing clusters. It means we are making the clusters with the same heterogeneity in the cluster. When we get to step 5, see step 5, this one. Here see distance 1 by 4, then 2, 2, 2, 2. But in after 5 are 2.2, and then it is 3.1. So when we get to step 5, we see a large increase. This indicates that joining clusters BCD, this BCD and EFG, then this one EFG, resulted a single cluster that was marked less homogeneous. So what we do, we make the cluster till the homogeneous units are found. But as we see the heterogeneity is coming into picture, So we should stop testing. So here see, we have taken number of clusters 6, means we have made all, only we have taken into consideration the units E and F on the basis of the similarity. See the distance between E and F. We can see here minimum distance 1.4. This one, E versus F. It is having the least distance 1.4. Now, so we have added E and F. Then we'll see which one to add with a similar close to 1.4. So which one is close to 1.4? We can see it is, I mean, it is 2. So this way you can add this one, this one. So this one, I mean, B and C with the D. So this way we can add similar item, and then E with the G having 2. So this way we can add different units to make the cluster. So this way, these are 6 clusters. Then we have added G with the F because it is having distance 2. See, we have added E with the F. Now G is very close to it, F. So we will add G to this E and F. So we the 3 observations or 3 objects, not observation, 3 objects will be in a single cluster, making the units together, putting the units together, E, F, and G. Okay. See, and this way, so now it reduces to 5 clusters. Then similar to this one, C and D are having, I mean, very close, because C and D is having 2 distance. So we will merge these 2. Then B and C. So to C and D, then B will be merged with the C and D, having the lesser distance. So this way we can add. So then see here, this B is added to C minus D. So this one, now it reduces to 3 clusters only. Now to similar to these 2 clusters, which one is will be added? So these 2 itself, they are similar to very close to each other. So these 2 will be merged to make 1. So this B, C, D, E, F, G. Now it reduces to 2 clusters only. Now A will be added. So at the 5th stage, we see the distance is very high, and so this will make the units under consideration in a single cluster. The units should be heterogeneous. So this way we can make the different clusters. Now, how many groups do we form? So now the crucial question is that how many clusters do we form? So there are 3 cluster solution of step 4 seems the most appropriate for the final cluster solution with 2 equal size clusters, that is B, C, D, having maximum distance 2, 1.4, then 2. And it is having also 2 E, F, and G. And since A is having more, I mean, distance having 3.1. So these 3 points with this one, 2, 3, this one, and then this will be the, I mean, separate cluster having only a single unit in a cluster. So this way we can see, we can observe that B, C, D, E, F, G, and a single outlying observation A. So this way we can form the 3 clusters here. This approach is particularly useful in identifying outliers. So this way we can, I mean, identify the outliers, outlying unit, such as observation A. It also depicts the relative size of varying clusters. The two are having three units, but it is having only one. Although it becomes unwieldy when the number of observations increases. So then I mean, we ignore this to see the relative size when the number of characteristics are increased. See here, this is the graphical representation of the example which we have shown. First, we have just group the two units E and F because they were having 1.414, I think, distance. 1.414, this one. So E and F. So this we have made this cluster. Then this cluster is merged with the C because it is having distance 2. So now that this is second cluster. So this first cluster, then second cluster, and then now come to this one. We have added D with C, the two units, and then this with the B because it is these two are having distance 2, and this is also having distance 2 from these two. So these clusters. Then now this one is different from. Now we these two clusters having three units are also having the distance 2. So now we merge them to make one cluster, and then the last one is merged with the. So this one is big cluster, then this one, then these two clusters, then inside this cluster, this cluster. So this way we can make the clusters either through algorithm method or by the division. Now you can see here, this is graphical portrayals. You can see here first this one E and F were added, and these then this was added with the G, and here you can see here B and C and D were added at third stage. Then this C and D was added with the B, fourth one, and now fifth one, since these two and these two were having the distance 2. So at fifth stage we added these two, and now the A was as the outlier. So this whole cluster is added to the this unit, so to make the single cluster. Now what is dendrogram? It is very important to see this. This is known as the dendrogram, that is tree graph. So graphical representation, a tree graph of the results of a hierarchical procedure. Hierarchically we have step by step we have done it. The dendrogram shows graphically starting with each object as a separate cluster, each object. The dendrogram shows graphically how the clusters are combined to each step of the procedure until all are contained in a single cluster this way. Now outliers removed or retained. This is very crucial questions. A question, if the outliers are very important, then we add them, and we consider them into further analysis, and if they are not important, then we can remove them. So outliers can severely distort the representativeness of the results if they appear as structure, that is cluster, as A was doing there in the example, inconsistent with the objective. If they are not consistent with the objective, then they will distort the representativeness. So definitely they will be showing the not homogeneous type structure, heterogeneous. So they should be removed if the outliers represents. When outliers should be removed? Aberrant observations, not representative of the population. If they are not representative of the population, they are not, relevant to the analysis, then we should remove them. Observations of small or significant segments within the population and of no interest to the research objective. Even they are, given in the population, but they are not meeting our the objective of our research, then we can remove them from the analysis. So they should be retained. Now counterpart of this one, they should be retained if a undersampling or poor representative of the relevant group in the population. If the sample, your sample is not well representative of the population due to undersampling or poor methodology, so we should retain them into the sample. The sample should be augmented, then we should increase the sample to ensure representation of the these groups. To represent the populations, then we should increase the sample size. Now, how we'll detect the outliers? Outliers can be identified based on the similarity measures, definitely, and the distance is very strong basis for the cluster analysis while identifying these outliers. So finding observations with large distances from all other observations. So the units or say observations having a high distance in comparison to other units under consideration, they will be considered as the outliers. So graphic profile diagrams highlighting outlying cases. Their appearance in the cluster solutions as single member or small clusters. They may have, single member cluster, or they may have one or two clusters, but having a huge distance from other clusters under consideration. Now, what should be the sample size? The researcher should ensure that the sample size is large enough to provide sufficient representation of all the relevant groups of the population. So this is a very crucial part of the research, that there must be an appropriate size of the sample for the analysis to be carried out. The researcher must therefore be confident that the obtained sample is representative of the population. As we used to say that the sample should be well representative of the population. So that is why the picture of sample size comes into the picture, that we should have minimum this size of the sample to make this sample as a well representative of the population. Now, what is the standardization of the data? How we standardize the data? So clustering variables that have scales using widely differing number of scale points or that exhibit large differences in standard deviations should be standardized. It means we are having a large variance or standard deviation, then they must be standardized. And we know that standardization is a process that if you wish to, standardize a variable, then what we do, we shift its origin and change its scale by the standard deviation and shift the origin at the mean. So what we do, suppose the variable is x, then x minus expected x upon standard error of x if it is statistic, otherwise standard deviation of x. So that is x minus expectation x upon square root of variance of x. So this way we do the standardization of the variable under consideration. So the most common standardization conversion is z-score. That is, z is nothing but it is x minus expected x upon square root of variance of x. So it is having 0 mean and 1 variance or standard deviation. So with the mean equals to 0 and standard deviation equal to 1. Now, how we derive the clusters? So there are a number of different methods that can be used to carry out a cluster analysis. These methods can be classified as follows. The first one is hierarchical cluster analysis. Second one is non-hierarchical cluster analysis. And the third one is the combination of the two, that is hierarchical and non-hierarchical methods. Now we first will discuss the hierarchical cluster analysis, the non-hierarchical, and the combination of it. So hierarchical cluster analysis The stepwise procedure, which we have discussed through an example, the stepwise procedure attempts to identify relatively homogeneous groups of cases, as we have done in the previous example, based on selected characteristics using an algorithm, either agglomerative or divisive, resulting to a construction of a hierarchy or tree-like structure, which we have discussed as dendrogram, depicting the formation of clusters. This is one of the most straightforward method, which is very much used while doing the cluster analysis. So in a CA, or hierarchical cluster analysis are performed when the sample size is moderate. It means if we are dealing with the sample size 300 to 400, not exceeding 1000. So if we are using the observations less than 1000, say, then we will apply the hierarchical cluster analysis. So two basic types of hierarchical cluster analysis are there, which we have discussed in the previous example with the endogram. One is agglomerative algorithm, and the second is divisive algorithm. So algorithm defines how similarity is defined between multiple member clusters in the clustering process. So what is agglomerative algorithm? Hierarchical procedure that begins with each object or observation in a separate cluster, as we discussed. All objects are considered as the clusters with a single object. And now we start hierarchically by adding one cluster to another. It means one unit to another, having the minimum distance. So on the basis of the minimum distance, we start adding the similar type clusters to make lesser number of clusters, and this is hierarchically done through agglomerative method. So in each subsequent step, the two clusters that are most similar are combined to build a new aggregate cluster. The process is repeated until all objects are finally combined into a single cluster, as we have done in the previous example, from n clusters to 1. And contrary to this one, we start with the one cluster and we go to the n cluster in divisive algorithm. So similarity decreases during successive steps. Definitely, as we start adding different clusters, then the distance is increased at different stages. So the similarity will be loses there. So clusters cannot be split. Now clusters cannot be split here. Now what is divisive algorithm? It begins with all objects in a single cluster, which is then divided at each step into two additional clusters that contains the most dissimilar objects. Here we consider, we split the two clusters into two parts having the maximum distance, that is dissimilarity. The single cluster is divided into two clusters, then one of these two clusters is split for a total of 3 clusters, then continues until all observations are in a single member cluster. What we started doing in agglomerative method. So from here we start from one cluster and go to n subclusters, and there we start with the n subclusters and go to the one cluster. Now see here, this is dendrogram or tree graph. We started with this one, one ENF, that is, this is the same example which we have discussed. We started, so agglomerative method is that E and F are merged, then E and F, the cluster having these two units is merged with the, first we consider all clusters with having single, observation, single unit. A, B, C, D, E, F, and G. Then E and F are merged with the same cluster. Then having the minimum distance 1.414, and then this E minus the cluster having two units E and F is merged with the G having distance 2. So this will make a cluster with having three units E, F, and G. Similarly, D, C and D is put together at third stage, and then B is also added to that group, and then these two groups are having the same distance. So these two are merged, and then this is merged with the A at last. And counterpart to this one, we start with a single cluster, this one, sixth one. Then we first break or divide the unit having the maximum distance, and that is A having 3 point something. So it is divided. Then at fifth stage, these two having having distance 2. These three unit. I mean this. Clusters having 2 units here and 3 units here. 3 units B, C, D, and having 3 units B, C, D, and E, F, G are separated, divided. Then we divide G from this, and B from this, then C from D, and E from F, and this way we get the clusters having 1 unit, single unit. Now, agglomerative algorithm, among numerous approaches, the 5 most popular agglomerative algorithm are there for the analysis: single linkage, complete linkage, average linkage, centroid method, Waltz method, and Mahalanobis distance. These are the agglomerative algorithm used for the hierarchical cluster analysis. So what is linkage distance? Single link. So also called a nearest neighbor method, and defines the similarity between clusters as the shortest distance. So here we consider the distance between the two shortest point of the two different clusters from any object in one cluster to any object in the another cluster. So what we do, we from this example we can observe that this cluster is having also 3 points, and this is also having 3 points, but these two points from two different clusters are having minimum distance. So these 2 points will be considered as the agglomerative algorithm for this using this single linkage. So this is the single linkage between the two clusters. Now complete linkage, it means the farthest point we add, also known as farthest neighbor method. The oppositional approach to single linkage assumes that the distance between two clusters is based on the maximum distance between any two members in the two clusters. So this one, the farthest one, this is farthest one. So this distance is the farthest one between the two clusters. Now average link, we consider the average of all the points. Suppose from this we consider the distance of this point, of this point, of this point, and then from this one, from this one, from this one, and from this one, from this one, this one, and we take the average of all the points, distances. The distance between two clusters is defined as the average distance between all pair of the two cluster members. This one, this one, this one, this one, this one, this one, and this one, this one, this one. So we take the average. So this is the average linkage agglomerative algorithm. Now centroid method, we take the average point of the separate clusters, and we join them. So cluster centroid are the mean values of the observations on the variable of the same cluster. So here we will take the average of these 3 points and average of these 3 points, and we put this is the average of these 3 points, and this is the average of these 3 points, and we will add them and we'll see the distance between the means of the points of the respective clusters, and this is known as the centroid method. the distance between the two clusters equals the distance between two centroids. These are known as the centroids. Now, what is Ward's method? The similarity between two clusters is the sum of squares within the clusters summed over all variables. So what we do in Ward's method, we do the square of this, square of this, square of this, and we add, and square of this, square of this, square of this, we add, and the distance between them. Similarity between two clusters is the sum of the squares within the cluster summed over all variables. So Ward's method tends to join clusters with a small number of observations, and it is strongly biased towards producing clusters with the same shape and with roughly the same number of observations. So if the suppose some points are farthest from all other points, and we'll take the square and do the sum, so definitely it will be strongly biased. Now we come to hierarchical cluster analysis. The hierarchical cluster analysis provides an excellent framework with which to compare any set of cluster solutions. This method helps in judging how many clusters should be retained or considered. So in hierarchical cluster, we are able to make how many clusters we are able in situation to decide how many clusters will be made for the cluster analysis. Now we come to non-hierarchical cluster analysis. Non-hierarchical cluster analysis, in contrast to hierarchical method, the NCA, that is non-hierarchical cluster analysis, do not involve the tree-like construction process. Instead, they assign objects into clusters once the number of clusters is specified. So here, what in hierarchical cluster analysis, we do not define number of clusters in advance, but in non-hierarchical cluster analysis, we define the clusters in advance, and on the basis of some characteristics, we define which object should be put in which cluster. So two steps in non-hierarchical cluster analysis: specify cluster seed and the assignment. So this is very important. We have to define the starting point, where to start, and then assignment of the objects to different clusters. So assign each observation to one of the cluster seeds. So we define the cluster seed, where to start the point, and then we start assigning the unit to different clusters. So non-hierarchical clustering algorithm, sequential threshold method, parallel threshold method, and optimizing procedure. These are the three non-hierarchical cluster algorithm. So all of this belongs to a group of clustering algorithm known as k-means cluster. So sometimes, especially in SPSS, non-hierarchical cluster analysis has been given with the name as k-means cluster. So it is also known as k-means clustering or k-means cluster method. So k-means method or k-means cluster method. This method aims to partition n observation into k clusters. So here we fix the k clusters and we put n observations in different k clusters on the basis of the similarity, in which each observation belongs to the cluster with the nearest mean. Here we consider the, on the basis of the mean of the cluster, we try to assign the different units to the predetermined number of clusters. So k-means is also commonly used, that the term is used by some to refer to the non-hierarchical cluster analysis in general. So k-means, it is also known as k-means cluster analysis. So what are the advantages of hierarchical cluster analysis? Similarly, we will be discussing about non-hierarchical cluster analysis. Simplicity, as we have seen. With the development of Endogram, the hierarchical cluster analysis so afford the researcher with a simple yet comprehensive portrayal of the clustering solution, as we have seen in the case of with an example. So now measure of similarity, SCA can be applied to almost any type of research question. So we can apply because we are not forming the cluster in advance. So on the basis of the similarity of the objects, it will form the clusters. Now speed, SCA have the advantages of generating an entire set of clustering solutions in the expedient manner. So through Endogram, we do that. So what are the disadvantages of the hierarchical cluster analysis? The disadvantages are to reduce the impact of outlier. So how we can reduce the impact? If we wish to reduce the impact of the outlier, so we have to remove them or we have to put them in different clusters. So the researcher may wish to cluster analyze the data several times, each time deleting problem observations or outliers. So this is the problem, that each time you have to check the outlier and you have to remove them if they are not important. So hierarchical cluster analysis is not amenable to analyze large samples. As we have discussed, if we are dealing with the more than 1000 data, then this is not appropriate method. There we will apply only the non-hierarchical cluster. So what are the advantages of non-hierarchical cluster analysis? The results are less susceptible to outliers in the data, while they are very much susceptible to the outliers for the in that hierarchical cluster analysis. The distance measure used and the inclusion of irrelevant or inappropriate variables, if they are even added to the non-hierarchical clusters, so it will not be very much affected. So non-hierarchical cluster analysis can analyze extremely large data sets. This is one of the very beautiful characteristics of the non-hierarchical cluster analysis. Now there are some disadvantages at the same time of non-hierarchical cluster analysis. Even a non-random starting solution does not guarantee an optimal clustering of observation, as we know. So we can not guarantee that if we have made say 3 or 4 or 5 clusters, so it is going to give the optimal result. So it does not give us guarantee. So in fact, in many instances, the researcher will get a different final solution for each set of specified seed points. As you are starting, you are making the different number of clusters, you will get the different solutions. So how is the researcher to select the optimal answer? Only by analyzing the validation can be the researcher. Can the researcher select what is considered the best representation of structure, realizing that many alternatives may be acceptable? So through practice, we will be able to see, by changing the number of seeds, we will be able to see which solution is going to be good or better or best for the analysis. So that much number of clusters we will make. Non-hierarchical methods are also not so efficient when a large number of potential cluster solutions are there. So this is also not very good, statistical analysis while dealing with the big data. So each cluster solution is a separate analysis, in contrast to the hierarchical techniques that generate all possible cluster solutions in a single analysis. So this does not provide such type of all possible cluster solutions. So thus non-hierarchical techniques are not as well suited to exploring a wide range of solutions based on varying elements such as similarity measures, observations included, and potential seed points. Suppose we are adding some observations and we are changing the seed points. So the similarity measures So there it will be very, very badly affected, and we'll find different cluster solutions. Now, combining the two methods, hierarchical and non-hierarchical cluster analysis. A combination approach using a hierarchical approach followed by a non-hierarchical approach is often advisable, because through hierarchical approach we will be able to form how many clusters should be formed there, and once we have formed there, then we will apply the non-hierarchical to assign the different units under consideration. First, a hierarchical technique is used to select the number of clusters and profile clusters centers that serve as initial cluster seeds in the non-hierarchical procedure, because we know the number of clusters to be formed. So a non-hierarchical method then clusters all observations using the seed points to provide more accurate cluster membership. So once we have decided, we have got the number of clusters, then on the basis of say distance and other measures, we assign the different units under consideration for using the non-hierarchical cluster analysis to get the better cluster solution. In this way, the advantages of hierarchical methods are complemented by the ability of the non-hierarchical method to refine the results by allowing the switching of the cluster membership. So on the basis of that, we will be able to see if there is any change, a particular unit should be placed in some particular cluster. Now the interpretation of clusters. The cluster centroid, that is mean of the all points of a particular cluster. A mean profile of the cluster on each clustering variable is particularly useful in the representation stage. So interpretation involves examining the distinguishing characteristics of each cluster profile and identifying substantial differences between clusters to find the distance between the different clusters. And cluster solutions failing to show substantial variation indicate other cluster solutions should be examined. If it fails to show the substantial variation among the say clusters, then we search for the search for another solution, cluster solution. The cluster centroid should also be assessed for corresponding with the researcher's prior expectations based on the theory or practical experiences. So on the basis of the prior information or say some pilot type study, we should decide the centroid points on the basis of which we will be able to I mean calculate the distance between the clusters under consideration. Now how we validate the clusters. So validation is essential in cluster analysis because the clusters are descriptive of structure and require additional support for their relevance. So cross validation empirically validates a cluster solution by creating two subsamples, randomly splitting the sample and then comparing the two cluster solutions for consistency with respect to the number of clusters and the cluster profiles. So we split them in two parts, two or more, and we on the basis of that two solutions we compare them to validate the cluster solution. So validation is also achieved by examining differences on variables not included in the cluster analysis, but for which a theoretical and relevant region enables the expectation of the variation across the clusters. If suppose we are dealing with some other variable which is not included, we considered it as not, I mean, very much relevant to our objective, but it is showing some variation among the clusters, then on the basis of that, we will validate the cluster solution. Now, how do we do the cluster analysis on SPSS? So we know that there are two types of basically or three types of cluster analysis we use in the SPSS. That is hierarchical cluster analysis, non-hierarchical cluster analysis, and two-step cluster analysis, that is known as the combination of the two. First, we define the number of clusters through hierarchical cluster analysis, and then we assign the observations. We see where there is any change of the unit, any shift of the units from one cluster to another in non-hierarchical cluster analysis, through non-hierarchical cluster analysis. So hierarchical cluster analysis, let us consider an example, and we'll be doing it the hands-on in SPSS after this theory will be over. So this file only includes say 20 cases, each responding to items on demographic, gender, qualification, days absence from work, whether they smoke or not, on their attitudes to smoking in public place, subtest totals for pro and anti, plus total scale score for self-concept. We are attempting to determine how many natural groups exist and who belongs to which group or each group. So what we do, how we do in SPSS, we go to analyze, then classify, and there we go for the, hierarchical cluster, then you can go for the k-mean cluster, and go for the two-step cluster. So there you can choose the method as well. You can plot the dendrogram this way. You can find the dendrogram here. And on the basis, this is the agglomerative method, and this way you can see the which clusters should be added with the least distance, then it will be added. So this is this dendrogram has been made on the basis of this, this table, and on the basis of these coefficients we can decide how many clusters should be made there. So you can see here, we'll be discussing how 1 and 7 is having least distance, then another one, which one will be added to this one and this one. This way we come to the situation that we should make the two clusters, because these clusters are having, larger distance, and but they are closer to each other. So this way we will be making the on the basis of the distance we will be making the number of different clusters, and we can have this idea as well from the dendrogram as well. So this way you can see here, these are the number of clusters, say 2, 3, 4, 5, and 6. So this way you can see the coefficient of these steps are there and how many changes there. So algorithm last step and then coefficient of these steps, and you can see the distance difference between the how much is the change in these two observations. So this way we will be discussing the this hierarchical, non-hierarchical, and two-step. This way we have to put the values of different characteristics for different units under consideration. So this way you have to put all the characteristics here, and then we go for the options. You can go for the descriptive analysis, you can go for the analysis of variance, you can go for the postdoc test as well. So there are so many options there to know the to do the analysis and to know the check the hypothesis and the consideration. So this way you can see this is ANOVA, and you can see how different characteristics are measured with the other characteristics. You can see. So on the basis of p-value, we will see which is going to be significant and which is not going to be significant. On the basis of the p-value, whenever the p-value is less than 0.05, that characteristic is significant. Otherwise, that is not significant. how to interpret the result on the basis of the similarity, on the basis of the distance, we will make the clusters, and then each cluster represents the similar objects under consideration on the basis of the all characteristics, or say clustering variable on the basis of under consideration. So cross type analysis of the nominal variables, gender, qualification, and whether smoking or not produced some significant association with cluster. So there we can apply the chi-square test as well to check whether the association of attributes is there or not. So this way you can see here gender versus which one? This is word method for calculating the distance, and this is smoke or not. This characteristic is checked with the say gender. So you can check the and we have made 3 clusters. You can see on the basis of the distances. So word method is used here, and word method, what word method do? It is consider the sum of squares of the all points in the single cluster. On the basis of that distance, we consider the distance between 2 points or 2 clusters. So consist of male non-smoker, consist of cluster 1 consists of male non-smokers, and cluster 2 consists of smoking and non-smoking males, and the third consists of smoking females. So here male and female. So this way we can make the clusters through cross tabulation. You can see here in this is the descriptive analysis. These are the mean, standard deviation for all the 3 clusters you can see, and these are the 95% confidence interval for the mean, and these are the minimum and maximum observation. So you can see here self-concept score, days absent last year, and total anti-smoking. These have been given the name to the different clusters, and this way you can calculate. So cluster 1 is characterized by low self-concept, average absent rate, average attitude score to anti-smoking, non-smoking males. As we have, because we have made the cluster 1 consists of male non-smokers, and cluster 2 is characterized by moderate self-concept, low absence rate, average attitude score, or anti-smoke, smoking and non-smoking males, and on the basis of all the characteristics under consideration into different clusters we can define. So the third cluster is characterized by high self-concept, high absence rate, low score to is anti-smoking and smoking of females, as we have decided the cluster. This third cluster consists of smoking females. Now we come to K-mean cluster, where we decide actually the in advance the number of clusters. So let us consider an example. Say the telecommunication provider wants to segment its customer base by service usage patterns. If customer can be classified by usage, the company can offer more attractive package to its customers. The following variables are taken for the analysis: multiple lines, voicemail, paging services, internet, caller ID, call waiting, call forwarding, three-way calling, and electronic billing. These characteristics have been considered to classify or cluster the customers of a telecommunication provider. So there you can apply the K-mean clustering. So you have to click on analyze, then classify, then go to K-mean clustering. And then there you have to define the number of clusters in advance. We have decided the 3 clusters, and maximum and minimum iteration you can fix. By default it is 20, and you can go for the options given in the SPSS. So K-mean cluster, you can go for the option. Initial cluster centers, ANOVA table, cluster information for each case you can have. So you click on continue and then click on OK. You will get this So here 3 clusters are made, and you can see the distances and the observations. The initial cluster centers are the variable values of the k well-spaced observations. With k well-spaced observations, which should be given in put in which cluster, you can see here. These are the characteristic under consideration which we have considered. On the basis of characteristics, these 3 clusters have been made, as we have set 3 clusters in advance. So now iteration history, you can see the iteration history shows the progress of the clustering process at each step, how they are how we are changing the units from one cluster to make cluster to on the basis of the similarity. So this is the ANOVA. You can check the significance of different characteristics. These are the 3 clusters which have been formed on the basis of the similarity. So this one cluster 2, cluster 3, and this way you can see. Now distance between final cluster centers, you can see 1 to 1 is 0, 1 to 2 3.5, and 1 to 3 4.8. So this one you can see from cluster 1 to cluster 3, it is highly distant from 3 is highly distant from first one 4.8. So the cluster 1 and 3 are most different, while first and second are, I mean, in comparison to third one, it is they are closer to each other. So this one you can see cluster 2 is approximately equally similar to cluster 1 and 3, because from 2 to 3 it is in distance 3.3, and from 2 1 it is 3.5. So they are very close to each. So you can see here now you can see here number of cases in each cluster, how many cases should be there in the cluster. So in cluster 1 it is 226, in cluster 2 it is 292, almost 300, and in cluster 3 these are almost 500 clusters out of 1000. So a large number of cases were assigned to the third cluster, which unfortunately is the least profitable group because it is having a high distance from other groups. So perhaps the fourth more profitable cluster could be extracted from this cluster basic service group. So now if this is showing that we should further split it in relatively homogeneous units. So now we can go for the non-hierarchical cluster analysis with 4 clusters, 4 seeds. So you can now we have made 4. So this way you can see these 4 clusters are given there. So third one was break into 3 and 4. So this one you can see here these 3 are I mean having almost similar distances, and the fourth one is having some large distance from there. So this one cluster 1 and 2 are the most similar, which makes sense because they were combined into one cluster together at the previous stage. So you can see here now all 4 clusters are having almost similar objects in all different clusters. So nearly 25% cases belongs to newly created group E. So fourth one 280. So this one and we have given it name as E services customer, which is very significant to your profit. Now we can make the policies on the basis of different 4 clusters, 4 type of services we can 4 type of offers we can provide to these 4 type of customers. Now 2 case cluster analysis we do. So automatically it decide the number of clusters, and then on the basis of that non-cluster analysis is performed there. So you can see here we go for 2-step cluster analysis. So this will be opened there, and you apply the continuous variable here and categorical variable here, and you can go for the option and then click OK. So you will have the analysis. So this way you can put the variables. So 2-step cluster analysis, there are so many options. Output, or in output you can check charts and all other things you can have. So this way the chart summary will be made. So this one is a cluster, then larger cluster. So this way we can have idea that how it is deciding the number of clusters, and then on the basis of the fixed seats, it assigns the number of observations to different clusters. So inputs are 7 and clusters are 3 here. It decides in 2 steps, and you can have some pie chart of for all 3 clusters, and you can see here 40%, 33%, 25% are observations are there in the 3 clusters. You can see here this way. We have a case study here. We consider a clustering of customers based on attitudes towards shopping. Based on past research, 6 attitudinal variables were identified. Consumers were asked to express their degree of agreement with the following statements on 7-point scale. 1 as strongly disagree and 7 as strongly agree. So these are 6 characteristics on the basis of which we have to cluster the customers. That question 1 is, I love to buy products in shopping mall. I buy discounted products. I enjoy eating food at shopping mall. I bargain products when shopping. I buy only daily need products, and I compare price of products in shopping malls. Okay, so let us do it in SPSS. So here these are the scores on 7-point scale by the 6 characteristics by the 25 customers. So now we go to analyze, then go to classify, and we go to hierarchical cluster. Here we select all the variables and put them into variables, and go to statistics. Then we algorithm schedule we use. If you wish proximity matrix, you can have also that one, and go for the plot. Then consider Endogram and click on continue. Then go to the method. So here these are the methods which are inbuilt automatically. They are used in SPSS. Otherwise, you can change them. Okay, so click on continue, and okay. If you wish to save some observation, then you can save. Otherwise, click on okay. So here you can see that it has formed 2 clusters with different observations, and you can see here this is the dendrogram, and you can see here what 2 clusters. This one, first one is this, and second one is this. So this one on the basis of the similarity. First, you can see here, first unit is added to 21, having the minimum distance. Then this is added to this 17th unit. So this one you can see, and these 2 units are added. So this one, this way, this cluster has been made on the basis of the distances, and this also on the basis of the distance. And so these 2 clusters are recommended because these 2 clusters are having significant distance, and that is why 2 clusters have been recommended. So you can see here on the basis of the table, you can see the coefficient distances, and on the basis of the distances, the units are selected into different. So these are different necessary. This way we have made the 2 clusters. So this was the hierarchical cluster analysis. Now we come to non-hierarchical cluster analysis. So you can go click on analyze, then classify, and then go to k-means cluster and select all the variables and put them in variables, and go to iteration. You can change from 10 to 20, and you can save some say cluster members, save distance clusters to the data, and click on go to the option, and You can have ANOVA table and case-wise cluster information and click on continue, and you can make here say it has made two, but suppose we wish to make the 3 clusters, then you can put here 3 and click on OK. So this way the 3 clusters will be made this way. And these are the different observations of the different persons. This way you can calculate. So these are the memberships you can see here. This unit is put into second cluster, this second unit at second, then third at third, then fourth at first on the basis of the distances. So this way we can form the final cluster on the basis of the distances. So these clusters have been formed. And this is the ANOVA. You can see here all characteristics are significant for all the clusters, you can see. So this way you can see that the 3 clusters and see that the distances 8, 10 and 7. So you can see here they are close to each other. So this way we can make the 3 clusters. Now we come to that, I mean, let us delete this one and this one. And now we come to analyze and go to classify, then go to 2-step cluster. So you can see here you have to put categorical variable here and continuous variable here, but here we have considered all continuous variables. So now you go to option, so you can use these options, otherwise no need. And you just if you wish to use them as standardized, or you have to make them standardized to be standardized. If you don't wish, you think that all are standardized, so select them here and put them here and then continue. And if you wish some output, then you can put the variables here. And if you wish the per table, then you can consider the options, otherwise you just click on OK. So this way you can see the different Bayesian information criteria, distances are used to see the number of observations with the different distances. So this way you can see that this is the cluster distribution, and you can see these are the centroid for the so this way you can see here 6 inputs, and it has made only 1 cluster because all points are almost similar to each other. So on the basis of that, it has made only 1 single cluster, because no outlier type observations are there. So on the basis of these distances, it has made only single cluster 1. So this way you can use either hierarchical cluster analysis or non-hierarchical cluster analysis, or you can go for the two-way cluster analysis. So this was all about today's discussion.